We've made it to Chapter 11. This is the first video of Chapter 11. We're going to discuss roots and zeros of equations or functions. Now I want to show you something really quick to remind you about leading coefficients and the degrees of a polynomial. In this one, the 5x to the third power is the first term, but it's not the leading coefficient, and that 3 is not the degree of the polynomial. It needs to be rewritten in descending exponential order because that's our leading coefficient, isn't it? Okay? And that 4 is the degree of the polynomial. Okay? So we can determine whether a number is a root or zero of a given equation or function. We need to remember that that coefficient of the term of the highest degree, that largest exponent, is the leading coefficient, like that 8x to the fourth power. And polynomials have the same properties of numbers and can be added, subtracted, multiplied, and divided. Now, when a number is substituted for a variable in a polynomial, the result is some unique number. So every polynomial defines a function. We often refer to polynomials using function notation, p of x. When we set a polynomial equal to 0, we obtain a polynomial equation, p of x equals 0. Now, the root of the equation, what is that? Well, if a number n is a solution of a polynomial equation, this p of x equals 0, then n is called the root of the equation. So if n fits in here in the place of x and it makes this true, then n is the root of the equation. And the 0 of the function, if a number n, when substituted for x, makes that polynomial function p of x a 0, then n is called a 0 of the function. So they're kind of related to each other, aren't they? And the roots to the equation x to the third minus 5x squared plus x minus 5 equals 0 are the same as the zeros of the function p of x equals x to the third minus 5x squared plus x minus 5. So take a look at this one compared to this one. Our difference is we have it equal to 0 here, and over here we've got it equal to p of x. See? Otherwise it's the same thing, isn't it? And zeros are appropriately named because they're the values for x that make the function 0. So we can determine whether the inverse of 5, a negative 5, or the inverse of I, negative I, are roots of the polynomial equation p of x equals 0. So where p of x equals x to the third minus 5x squared plus x minus 5, wherever there's an x, we're going to put this inverse of 5, this negative 5. So we've got x to the third here, so we're going to put a negative 5 to the third. Well, negative 5 times negative 5 is positive 25 times negative 5 is a negative 125, isn't it? We put it in place of the x squared. We got negative 5 squared. That gives us a positive 25. And when we multiply it by this negative 5, we get minus 125. We put it in place of this x. And now we're adding a negative 5, which is subtracting a 5. And we've got our minus 5 here. So these two make a negative 250, and when we subtract 10 more, we have negative 260. Now, negative 260 doesn't equal 0, so that's false. So we know that negative 5 is not a root of the equation. It didn't make it equal 0. It didn't work. Now let's take a look at this inverse of I, this negative I. We're going to put it everywhere there's an x, okay? So I want you to remember from video 7.7a, if you get confused about this I business, we talked all about I for several videos starting with 7.7a. And I to the first power is equal to I squared is equal to a negative 1, I to the third power is equal to a negative I, and I to the fourth power is equal to 1. And we discussed that. So we're going to put a negative I everywhere there's an x. And when we have negative I to the third power, what's happening is we're going to just get an I. When we have negative I to the third power, we can split this 3 into a 1 and a 2. So we have a negative I to the first power times negative I squared. And that's going to give us a negative 1. So we have negative I times negative 1. That's going to give us just an I. All right? And again, if you're confused, 7.7a, there's a link in this description, okay? And that was back in chapter 7. So when we put this negative I squared in place of x here, we just get a 1 See? Minus I, that's this one right here in place of the x, and then we have minus 5 equals 0. This I plus 5 times 1, well, that's just a 5. And then we have minus I minus 5. Well, I plus 5 minus I minus 5, well, that's a 0 pair, isn't it? That's additive inverses. I plus 5 minus I minus 5. So 0 equals 0. So substituting this negative I, this inverse of I for x, makes a true equation. That means the inverse of I is a root of the equation, p of x equals 0. Okay? I know this could be confusing for some, but the only reason it would be confusing is if you don't understand I, all right? And that's where you find it, okay? Let's try this again. Let's try another example, all right? So we can determine whether the given numbers 3 or 2i are zeros of the polynomial function p of x, where p of x is given by x to the third minus 3x squared plus x minus 3. So everywhere there's an x, we're going to put in a 3. And then in our next example, everywhere there's an x, we're going to put in a 2i. Okay, so here's the 3. So we're evaluating the function p of x for x equals 3. So this was our equation, our function. So everywhere there's an x, we're going to put a 3. That means we've got p of 3 equals 3 cubed. And 3 times 3 is 9, times 3 is 27. 3 times 3 is 9, times a negative 3, it's minus 27. And we put our 3 here for our x. This 27 minus 27 gives us a 0. And if we had 3 minus 3, that's another 0. So it's 0. And p of 3 equals 0. So 3 is a 0 of the function. It made this equal 0. See? Let's try it with 2i. So remember, those are our values for I, okay? So now we're evaluating this function p of x for x equals 2i. So everywhere there's an x, we're going to put a 2i. So x to the third, we have 2i to the third. That's going to give us a negative 8i. We've got 2i squared. Well, that's a 4 times a negative 1. We need to multiply it by this negative 3. That's going to give us a positive 12. We put our 2i in place of that x, and we have our minus 3. This negative 8i plus 2i is going to give us a negative 6i. This 12 and a negative 3 minus 3 is going to give us a 9. So that means p of 2i does not equal 0. That means 2i is not a 0 of the function. So remember, when we substitute a value for x that gives us p of x equals 0, then that value for x is a 0 of the function and a root of the equation. We want it to equal 0, all right? We want that to be true. So I hope this was helpful. We're going to continue on, and our next video, 11.1b, is going to be how to determine if a polynomial is a factor of another polynomial with division. And there's going to be a link to that values of I from 7.7a in here. And I'm going to add this to the Algebra 2 playlist, and I hope you're doing well. And I hope this was helpful. I'll see you next video. Bye.